What is an electron emission? It is the process of liberation of electrons from the metal surface is called as electron emission. The maximum kinetic energy of the photoelectrons depends on the frequency of incident radiation, but it is independent of the intensity of radiation. Light is made up of photons, which are nothing but a quanta, which means a small packets of energy. Hello everyone, welcome to session 1 of chapter 11, Dual Nature of Radiation and Matter. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Dear children, in this chapter we are going to understand the dual nature of light. So what is the meaning of dual nature of light? Light exhibits two natures called dual nature. One is a particle nature, the other one is wave nature. So it's a very simple and smallest chapter among your syllabus where we are going to understand the properties of light. How does it exhibit its dual nature? When does it behave like a wave? When does it behave like a particle? What are the concepts that helped us to understand the wave nature of light as well as the particle nature? So let us begin with the introduction part, that is the discovery of the phenomenon like interference. We know what is interference, diffraction and polarization. They concluded that the light has a wave nature. So in the interference pattern, diffraction phenomena as well as the polarization phenomena, we will understand the wave nature of light. It will not tell us about the particle nature of light, whereas in case of photoelectric effect and also about the study of cathode rays and X-rays, they are having a stream of particles and they explain us how does the light behaves like a particle. So few phenomena of light explain us how does the light behaves like a wave, and few of the other studies helped us to understand their behaving as a particle. So only light, since it behaves like a wave as well as a particle, we have concluded that light has dual nature. So in this chapter we shall understand these two natures of light. So after William Crookes observed the irradiation of certain light which emits particles as well as the Hertz observation, there was a concept called electron emission which was under discussion, which helps us about how does the electron that emits from a metal surface when radiation of suitable frequency incident on it, as well as what are the different parameters for the electron to emit from the metal surface. So electron emission is one of the important concept in understanding the dual nature of light. What is an electron emission? It is the process of liberation of electrons from the metal surface is called as electron emission. So the name itself clearly says electron emission is nothing but the process of liberation of electrons from the metal surface. So the electron has to liberate from the metal surface, has to come out of the metal surface, means it should have some external energy. We should supply some external energy. We should give the potential for the electron to come out of the metal surface. Then what are those type of external energies that we can give, or what are the different types of electron emission based on the source that the electron can gain to come out of the metal surface? So there are three types of electron emission. The first one is thermionic emission. The second one is field emission, and the third one is photoelectric emission. So these are the three different types of electron emission based on the source. So what is thermionic emission? So in case of thermionic emission, the electrons will come out of the metal surface, or the electron will liberate from the metal surface when a temperature increases. When a radiation incident on a metal, because of the temperature, the electrons gain the energy and they come out of the metal surface, which means, is a normal temperature enough for an electron to come out of the metal surface? No. When the metal is heated with sufficiently high temperature, the electrons will gain energy and they start liberating from the metal surface, and such type of emission is called as thermionic emission. So in this method, the thermal energy is the reason for the electrons to come out of the metal surface, and those electrons which liberate from the metals are called as thermoelectrons. So what are the factors on which this thermionic emission depends on? It depends on the nature of the metal and also it depends on the temperature. A sufficiently high temperature is irradiated or it is passed to the metal surface, only then the electrons will come out of the metal surface. So these are the two important factors on which the thermionic emission depends on. So you may get a doubt that what is the approximate temperature or what is the range that the metal should be heated to liberate the electrons. That is about 2500 degrees Celsius. So this is the ideal temperature where the electrons can gain energy and they can liberate from the metal surface. So this is about the thermionic emission. Now we shall study about the field emission. As the name suggests, field. What kind of field we are talking about? So we are talking about the electric field, which means in field emission, it is the process of liberation of electrons from the metal surface when the strong electric field is supplied to a metal surface. So what is the range? That is 10 power 8 volt per meter. For about 10 power 8 volt per meter amount of electric field, a strong electric field is supplied to a metal surface, the electrons will gain the energy and they will come out of the metal surface. This kind of liberation of electrons is called as field emission. So in this process, the stronger the electric field, the large number of electrons will come out from the metal surface, which means the number of electrons that liberate from the metal surface is directly proportional to strong electric field. As the electric field is more and more stronger, number of electrons that liberate from the metal surface will also be higher. So now in this case, what are the factors on which the number of electrons that emit from the metal surface depends on? It again depends on the nature of material and also it depends on the intensity of strong electric field. So based on the nature and the intensity of electric field what we supply, the number of electrons will liberate accordingly. So these are the two factors which number of electrons liberation depends on. So the next and the last type of emission is photoelectric emission. We know what is the meaning of photo. It is nothing but light. So when a radiation of suitable frequency incident on a metal surface, the liberation of electrons takes place. Or we can even say when a light of suitable frequency incident on a metal surface, the photons will pass energy to the electrons and hence the electrons which are present on the metal surface will emit, will liberate. So this process of emission is called as photoelectric emission. So photoelectric emission also depends on the intensity of incident radiation. It also depends on the nature of material. It depends on intensity of the light or supplied radiation, which is nothing but light in case of photoelectric emission. So these are the two factors on which the photoelectric emission depends on. So these are the very important concepts when it comes to electron emission. So basically we can say that the electrons can liberate from the metal surface when it gains energy from the external source. So these are the three types of electron emission based on the source we give to the electrons to come out of the metal surface. So in photoelectric effect, we can say that the electrons that liberate from the metal surface are called as photoelectrons and the current due to these photoelectrons is called as photoelectric current. So these are all related to photoelectric effect. The electrons which come out of the metal surface are called as photoelectrons. Current due to these photoelectrons is called as photoelectric current. So the next important concept in the study of photoelectric effect is Einstein's photoelectric equation. So we all know that Einstein awarded honorable award because of his contribution in the photoelectric effect. So what is this equation of Einstein of photoelectric effect? So before studying about the equation, according to Einstein, when a photon is incident on a photosensitive material, if the energy of the photon increases or exceeds the work function phi naught, then the maximum kinetic energy of the electrons will be observed, which means the electrons will gain the maximum kinetic energy. So according to him, when the photon of energy h nu is incident on a metal surface, if the energy of the photon exceeds the work function, then the electrons will gain maximum kinetic energy. The equation is given by h nu is equal to work function, that is phi naught plus kinetic energy or maximum kinetic energy. So his equation is nothing but h nu is equal to phi naught plus kinetic energy, or we can write kinetic energy. The maximum kinetic energy is equal to h nu minus phi naught. This is the equation of Einstein for photoelectric effect, where h nu is nothing but h stands for Planck's constant and nu stands for frequency, and phi naught is nothing but the work function. What is this work function? It is phi naught is equal to h into nu naught, where h is a Planck's constant and nu naught is nothing but a threshold frequency. So what do you mean by threshold frequency? It is nothing but the minimum frequency which is required for the electrons to come out of the metal surface. So the minimum frequency that required for the liberation of electrons is called as threshold frequency, and the work function is defined as h into nu naught. So this is about the equation of Einstein for photoelectric effect. What is his explanation about the photoelectric effect? Einstein also explains about the photoelectric effect, and this first explanation is the photoelectric effect is instantaneous. It takes place at particular instant of time, or at that instant of time, which does not require much time for the process to take place. It is instantaneous. So that is his first explanation. He also says that the maximum kinetic energy of the photoelectrons depends on the frequency of incident radiation, but it is independent of the intensity of radiation. So always the kinetic energy of electrons depends on the frequency, but it is independent of intensity. And also he concludes about the threshold frequency. It's a minimum frequency required for the electron for the photoelectric effect to take place, or below the minimum frequency or below the threshold frequency, no liberation of electrons takes place, or no photoelectric effect can be observed, and hence he named it as a threshold frequency. So these are the explanation of photoelectric effect according to Einstein. He also says that photoelectric current, that is current due to photoelectrons, photoelectric current is dependent on intensity but not on the frequency. But here we have studied about that the kinetic energy depends on the frequency, not on intensity. That is his second observation. He also says that the photoelectric current is dependent on intensity of the incident radiation, but not on the frequency of incident radiation. So these are the explanation of Einstein regarding photoelectric equation, and this is Einstein's photoelectric equation, which is very important examination point of view. Now we shall study about the particle nature of light. So when can we observe that light has a particle nature? Light, when interacted with matter, it behaves as if it was made up of a quanta, which means a small package of energy is called as a quanta. Light is made up of photons, which are nothing but a quanta, which means a small package of energy. So each quantum has energy h nu. H is a Planck's constant and nu is its frequency. So these particles which are associated with the quantum of energy are known as photons. We usually say that light consists of photons. What does it mean? It is nothing but the small packets of energy or small quanta of energy. So the photon energy and momentum depends only on the frequency of radiation. It is only dependent on the frequency of radiation. So they are electrically neutral. We all know that the photons have no charge. So they are electrically neutral. Therefore, the rest mass of the photon is zero. We can also say these as the characteristics of photons. The rest mass of the photon is zero and they are charge independent, they are electrically neutral. So the next important concept is de Broglie wavelength. So according to de Broglie, if a light possesses dual nature, then the moving materials also possess same nature, or the matter, the particles which are present in the matter also possess same nature. So The waves that associated with moving particles is called as matter waves. So according to de Broglie, the matter waves, which means the waves that are associated with moving material particles. So who proposed the matter waves? If the question comes, then it is nothing but the de Broglie. According to him, the waves associated with moving material particles are called as matter waves. So he concluded this by taking consideration of dual nature of light, that is, sometimes light behaves like a wave, sometimes light behaves like a particle. So if this is true, then the moving material particle should also behave like a dual nature, and he called the waves that associated with moving material particles as matter waves. So the wavelength that associated with moving material particles is called as de Broglie wavelength, or we can say that the wavelength that associated with the matter waves is called as de Broglie wavelength. So the expression for de Broglie wavelength is given by lambda is equal to h divided by P. So what is this h? H is Planck's constant and P is the momentum. So lambda is the de Broglie wavelength. So according to de Broglie, the de Broglie wavelength for photon is nothing but h divided by mc, where P is equal to momentum, that is equal to m into c, where m is mass of the particle and c is the speed of light. So according to de Broglie, the de Broglie wavelength for a particle is h divided by mv, where h is a Planck's constant, m is mass of particle and v is the velocity of particle. But now the question is how to arrive at this expression. So we know that the energy of the photon is nothing but E is equal to h nu, and also we know about the energy is nothing but E is equal to mc square. So this is my equation 1 and this is my equation 2. So from 1 and 2 we know that the LHS part is E only, so we can equate these two and we get h nu is equal to mc square, or we can write h nu divided by c square is equal to m. So or we can write it as h nu divided by c is equal to, one of the c I'll multiply to RHS, we can write it as EMC. But we know that P is equal to EMC, that is momentum. So I can replace h nu divided by c is equal to P. But we know that c is equal to nu lambda. So when c is equal to nu lambda, substitute here, we get h nu divided by nu lambda is equal to P. Nu gets cancelled and we remain with P is equal to h divided by lambda, which is nothing but the expression for de Broglie wavelength. And from this expression we can write lambda is equal to h divided by P is an expression for de Broglie wavelength. So this is how we can assume the energy of a photon and energy of any particle, that is E is equal to mc square, substituting, and we arrive at the expression lambda, that is de Broglie wavelength, which is given by h divided by P, called de Broglie wavelength. So what are the properties of this de Broglie wavelength? So this de Broglie wavelength is smaller for heavier particle. That is the first concept or the characteristics of de Broglie wavelength, that is lambda is smaller for heavier particle. So de Broglie wavelength is also associated only with the moving particles, which means if the particle is at rest, then the de Broglie wavelength is 0. The de Broglie wavelength is 0 for the particle which is under rest. It is only applicable for the particle which is in motion. So this de Broglie wavelength is only dependent on the mass, the speed of the particle, and it does not depend on the charge on the particle. These are the basic and important characteristics of lambda, that is de Broglie wavelength. Dear children, in this session we have learnt about some concepts that are related about a dual nature of radiation and matter. In this, the very important question that we can expect for examination is the types of electron emission as well as the Einstein's photoelectric equation. So in the next session, we'll come up with new concept. Until then, keep learning all of you. Thank you.